Right now, there are over 8 billion humans on this planet. We've spread into every corner of it: deserts, mountains, Arctic ice, tiny islands in the middle of nowhere. It's easy to assume our species was always destined to take over the world, but there was a moment buried deep in our past when the entire human race came within a hair's breadth of disappearing completely. And almost nobody knows it happened. Here's the number that should terrify you. Around 70,000 years ago, the total global population of Homo sapiens may have dropped to somewhere between 1,000 and 10,000 breeding individuals. Not 10,000 tribes. Not 10,000 in one region. Potentially the entire species worldwide reduced to a number smaller than a small town. Finding the bottleneck. This idea comes from something called a genetic bottleneck, and scientists found it by looking at something you'd never expect: the DNA of everyone alive today. In the 1990s, geneticists began comparing mitochondrial DNA, genetic material passed only from mother to child, across human populations worldwide. What they found was strange. Modern humans, despite living on every continent, are genetically far more similar to each other than almost any other species on Earth, including our closest primate relatives who never left a handful of forests in Africa. Chimpanzee populations living within a single national park in Africa show more genetic diversity than the entire human race spread across the globe. That level of genetic uniformity is the fingerprint of a population crash. Something reduced our ancestors to a small enough number that everyone alive today descends from a surprisingly narrow genetic pool. What almost killed us? So what happened? The leading theory points to a volcano. Around 74,000 years ago, Mount Toba in what's now Indonesia erupted in one of the largest volcanic events in the last 2 million years. It was thousands of times more powerful than Mount St. Helens. Ash from the eruption has been found as far away as India and East Africa, buried in layers up to 15 centimeters thick, thousands of miles from the volcano itself. An eruption of that scale would have thrown enormous amounts of sulfur and ash into the atmosphere, potentially triggering what scientists call a volcanic winter. Years, maybe a decade, of dramatically cooled global temperatures, failed vegetation, and collapsed food chains. For a species that depended entirely on hunting and foraging, with no stored surplus and no agriculture, a multi-year climate collapse wouldn't just be inconvenient. It would be an extinction-level event. Anthropologist Stanley Ambrose proposed in the 1990s that this eruption, combined with an already cooling Ice Age climate, could have pushed the global human population down to the edge of survival, isolating small surviving bands from each other for thousands of years. The debate. Not every scientist agrees the Toba eruption was the cause. Some archaeological sites in India show stone tools continuously produced both before and after the ash layer, suggesting some human groups survived the eruption relatively undisturbed. Critics argue the bottleneck might have had a longer, slower cause: general Ice Age climate instability, repeated droughts in Africa, or a combination of smaller crises stacked over tens of thousands of years rather than one single catastrophic event. But here's what almost nobody disputes. The genetic evidence for the bottleneck itself is solid, even if the exact trigger is debated. Something, or some combination of somethings, brought our species down to a population small enough that a handful of bad years could have ended us entirely. What survival actually looked like. Some of the strongest supporting evidence comes from South Africa, at a site called Pinnacle Point, overlooking the Indian Ocean. Archaeologists found evidence that small groups of humans survived this period by relying almost entirely on the coastline, harvesting shellfish, a stable food source that didn't depend on unpredictable land animals or crops. These caves also contain some of the earliest evidence of symbolic behavior in humans: pigment use, deliberately shaped tools, early signs of complex thought. In other words, the humans who survived this near extinction weren't just lucky. They were adapting, innovating, and developing exactly the kinds of cognitive tools, problem solving, symbolic thinking, tighter social cooperation, that would eventually let their descendants leave Africa and populate the entire planet. That we're here. Every single human being alive today, all 8 billion of us, descends from that surviving population. Every language, every culture, every war, every invention, every person you've ever loved or lost traces back through an unbroken line to a group of people who were at one point small enough to fit in a stadium, clinging to survival on a handful of coastlines. If that eruption had been slightly larger, or the following winter slightly longer, or one more bad harvest had hit those coastal groups, none of this would exist. Not because humans are fragile in general, but because at that specific moment, we were. So here's the picture. Roughly 74,000 years ago, a volcanic eruption of almost unimaginable scale may have plunged the planet into a years-long winter. Somewhere in the aftermath, the global human population may have crashed to as few as 1,000 breeding individuals. The genetic evidence for that bottleneck is written into the DNA of every person alive today, and the small groups who survived, clinging to coastlines and adapting through pure ingenuity, are the reason any of us exist at all. We tend to think of human dominance over this planet as inevitable, like it was always going to happen this way. But the genetic record tells a much closer story. At some point in our history, our entire species came close enough to disappearing that a slightly worse decade could have erased us before we ever left Africa. You are not descended from an inevitable success story. You're descended from a small, stubborn handful of survivors who refused to be the last chapter.